So welcome everyone to the Self-Driving Cars 101 February event. I'm glad that you are all here. I hope that you all remember why you are here, and in case you don't, I will remind you. The reason why we have these events is so that we can put all of you in touch with the people who are actually building and creating the future, so you can hear straight from them the truth, rather than the sensationalism that comes out of media and everything else. So what does that mean? That means that you are then expected to go out into the world, into your communities, and share what's actually going on with your neighborhoods and with your friends and co-workers, so you become kind of a vortex of truth. How about that? Yes, you could put that on your LinkedIn page, vortex of truth. All right. So one other announcement before we get started. So as you can all see, our events are getting big, and almost too big. And so whereas Self-Driving Cars 101 has been doing both terrestrial and airborne, therefore our eVTOL panel, it's getting too big, and I'm running out of venues that can hold us all. So I have created a new meetup called Autonomous Air, which will focus directly on UAM, urban air mobility. So if you are particularly passionate about UAM, I would invite you to join the Autonomous Air meetup. And we will be meeting every other month with specifically UAM providers, infrastructure, really focusing and digging deep on those areas. And self-driving cars will return to its roots of vehicular automation and autonomous vehicles in that front. Okay, so to get ourselves started, let me introduce our panelists. I'm just going to call them up and have them have a seat, and then they're going to share with you, once they're all seated, they're going to give you a quick 1 minute on who they are and why they're here, and then we're going to dive into the questions. When we have 4 questions, actually the last question's a double header, I'll keep that on secret. When the questions are done, then I'm going to take questions from the audience. So if you have a question as we go, just kind of keep it in your head, and we'll get to you later. And then afterwards, we're going to have more time for networking. And as I do every event, I want to encourage each and every one of you to walk up to somebody you do not know and introduce yourself and make a new friend tonight, because that's part of what these events are about. Okay, so let's call up to the front Mr. John Demouche. With Boeing. He is with Boeing's next group. Adam Warmoth, who is with Uber Air. He is their product lead. We got Matthew Holvey, who is, his title is way too long. He's with Bell. I'll just go with that. He can tell you what his title is. And then we have Thomas Farrell, who is with Joby Aviation, and he is their head of certification. All right, so John, we're going to ask you to start and give us a quick rundown on who you are, and then we'll move to the left.
Sure. So my name's John Damish. I'm a senior director inside Boeing, specifically inside Boeing's Next group. For those of you who don't know what that is, this is our kind of innovation team. So we're looking at the next 50 years of aviation, 100 years of aviation. What can Boeing do? What should Boeing do in that space, both to continue to be, the company that we are as Boeing, and make sure that we stay aware and place the right bets in this area of technical growth and how mobility is going to transform over the next century.
All right. Next up.
Awesome. Yeah, so I'm Adam, product manager with Uber Elevate. Been on the team for 2.5 years now. Started on the vehicle requirement side, then work on basically commercializing our product with Uber Copter, Uber Eats drones, and eventually Uber Air. Previously worked at Kitty Hawk, kind of on the manufacturing side as well. So happy to be here and help advance Uber's mission of weaving the everyday flight of people and things into everyday life.
Hey, I'm Matt Holvey from Bell. I'm the manager of Intelligent Systems. I'll give the short title today.
Why don't you give the long title?
The manager of Innovation Operations, Specialty Engineering, and Intelligent Systems.
So you didn't think I was pulling one over?
Yeah, okay. find my column. And so Bell is known for its wonderful helicopter aircraft and the V-22 Osprey that takes off like a helicopter and flies like an airplane. It's called tilt rotor. But we recently reinvented ourselves last few years. We are now a technology and mobility company. And as part of that innovation and digital transformation, I came to Bell within the innovation team to apply machine learning tools and predictive analytics and fleet management software to urban air mobility.
Hello everyone, my name is Tom Farrell. I work for Joby Aviation. I'm a senior certification engineer and what's called an FAA designated engineering representative, which basically means I make findings of compliance on behalf of the FAA. So I'm part of an overall certification team that's helping to get our vehicle through FAA certification. Joby is in the business of building electric vertical takeoff and landing aircraft. We're the newbie among all of these fine individuals up here. So glad to be here.
Cool. All right, so let's roll right into the first question. Everyone, I will be projecting the questions up here. So the question is, what are the greatest challenges facing eVTOL development, UAM development today? You can either go in order, you can raise your hands, you can fight it out, however you want to address it.
I'm okay going last.
I'll start us off. You know, from our perspective, the biggest challenges we have are twofold. Number one is certification. History is littered with a lot of companies that have built a lot of really fancy and cool airplanes, but there's a lot fewer aircraft companies that have actually managed to get them through certification. Certification is a mountain of work. It's a mountain you can't go over, you can't go through, you can't go around, you can't skip it in any way, you have to climb it. And that means writing requirements, validating your design, lots and lots of testing, including building airframes that all you're going to do is break them. So it really is what separates companies that want to play in this space and companies that are actually going to make money. The second big challenge that we have beyond certification is public perception. You know, everyone says, well, gee, you know, we can fly helicopters now. Well, no, we really can't, because there's a lot of NIMBY, not in my backyard. They don't want helicopters flying in and around urban settings. People are afraid of them. They make lots of noise. They have lots of downwash. So for eVTOL to be successful, we need airplanes that are much, much, much quieter and have incredible safety on par with what we have for commercial transports today.
Yeah, I would totally agree with my answer was going to be community acceptance, and it's in two buckets, but they're actually kind of one and the same. One is, am I okay with this flying around my neighborhood, and do I see myself flying in one of these? And while those initially are two separate problems, they're kind of the same. I'm going to be okay with this in my neighborhood if I see this bringing value to my life, if I see myself using this product. So it's teaching people that everyday flight, it's not just a thing for the rich. It's a thing, something that they can benefit from every day. And then that's going to help them come to terms with these things flying in their neighborhood. And eVTOL are going to be a lot quieter than helicopters, lower emissions, zero emissions. But they still have to have the community feel like they're engaged in it and not just allowing it.
So not to get super technical, but can you explain to people why they're going to be quieter?
I can. You'll probably do a better job of it.
Closing the loop on the noise conversation, you know, getting on the wing. You'll probably hear people in the industry say this a lot. It means transferring weight from vertical lift to horizontal flight, and the weight is borne by the wing of the aircraft. The beauty of doing that is you then greatly reduce the power required to keep the aircraft aloft, which then has a direct effect on the amount of noise that the aircraft is producing. So I agree with everything the rest of the panelists have said. To the original question, I'd add two different perspectives, or additional perspectives, not different. The first one, the limitation is capital. You know, the certification path, Thomas is absolutely right. You have to do it. There is no excuse. There's no shortcut. You're going to carry people. Safety has to be first, and the system that's in place today is actually quite good. Nothing new has to be invented there. You just have to go through the process. That takes resources, that takes time, which equates to capital. So availability of capital is absolutely one of the constraints on the growth of UAM in this space.
How much does it cost?
A lot of money.
$100 million?
Starts with a B.
Oh, that's easy.
Yeah.
That's easy.
Yeah. So that's one. And I think the second thing is, and this kind of correlates to capital, is that the business model has to be clear and make sense for that capital to be allocated. And the challenge of any airborne business model is utilization. You can just look back at the airline business from its inception to today and the amount of consolidation that happens in airlines. And it really comes down a lot to asset utilization. These are very, very expensive assets. Yes, we're all up here. Yes, we're all pushing to build aircraft that are more affordable, that use more commercial off-the-shelf components, that allow us to democratize air travel to a broader mass. Like, we're all aligned in that common goal. But the truth of the matter is, it's probably always going to be more expensive to make something that flies than it is to make something that drives. So you have to have a business model that supports that. The way you make those assets make money for you is by utilizing them at a very high rate. Airliners rarely sit on the tarmac. They fly. If you have airplanes on the ground, you are losing money. A 737 costs $100 million, roughly, right? You have to be able to utilize that asset, fill those seats to have the business make sense. So I think as you look at the eVTOL space going forward in urban air mobility, the plus side is we're talking about smaller vehicles, right? We're not talking about filling 150 seats. Yay, okay, cool, that helps. The hard side, and this is where our friends at Uber, I think, do have an advantage and a right to win in this space, and that is aggregating demand so that the operators can fill the seats. As you go more and more ad hoc, it gets harder and harder to pool, right? The airlines, it's great. We got fixed routes, everybody knows it, you advertise that, you fill the seats, you have a lot of price elasticity in there to try to fill those seats, and you go fly your airliner. On demand, I want to pull out my app and I want to ride today, that's going to be more challenging, and systems like what Adam builds help fill that demand. So that's kind of my perspective on the question.
So I think that is, that kind of leads into our next question. And this is a really, really huge question, right? And it's a question of what are the biggest changes that we're going to see to our society that UAM and eVTOLs in particular are going to bring to our society. I know there's a lot of questions around, well, wait a minute, I know how SFO works, right? I get how airports work. But when we start moving to like vertiports, and we're not talking about, to your point, like these VTOLs can't cost as much as a giant plane does, or else we won't have enough of them, right? Because we're trying to actually create an urban air mobility, an option to a car. And they're going short distances, and we want them to go a lot and often, right? So that starts to raise all kinds of questions around, well, wait a minute, SFO is a cluster at any point in time. So are you saying that you're going to put an SFO in the middle of San Francisco, in the middle of Dallas, in the middle of wherever? And what is that going to do to traffic? And what is that going to do to all kinds of stuff? How are you guys approaching all that?
Yeah.
Matthew's dying to answer this.
I am, and I'm going to cheat a little bit because I feel like I had this conversation earlier today with somebody. But first and foremost, the impact is that human patterns are going to change, right? We're going to do things differently than we do them today. And some of those are going to be unpredictable. There are unknown unknowns out there. We don't fully understand exactly how people are going to move and interact around the urban air mobility ecosystem that we want to deploy. We're going to predict that as best we can. We're going to survey the heck out of that, right? We're going to get early adopter buy-ins. We're going to do proxy air taxi demonstrations that Adam could probably talk a lot about, right? But at the end, until you deploy it, you're not really going to know how humans are going to change their behaviors and what new problems, shifting the bubble, if you will, might come up because of that. And we'll just have to kind of face those as we go. That was a little abstract answer, and I've got more content, but I'll yield the floor for a second.
Adam, why don't you weigh in?
Yeah, I think as a quick response to that, yeah, I mean, that was the thesis behind Ubercopter. And that's why we're operating, I'm not sure if everyone knows, we operate a helicopter service from downtown Manhattan to JFK, utilizing this multimodal technology and basically using this as a test bed for all the products and services and behavior studies of how people are going to interact with a service like this. You mentioned things like traffic around the vertiports. We've had to go and look at how do you update your Waze and Google Maps to get the drivers to turn into the parking lot of the heliport. And there's a bunch of stuff. I was telling John earlier today, we knew we were going to learn a lot, and that's what we talked about, the unknown unknowns. And so we said, we're going to go do this, we're going to learn a lot. And we've learned things that we never would have imagined that we would have needed to learn by kind of operating this service on a daily basis. And as you scale, there's always things that are going to change, but operating that service gives us a great platform to learn about how people are going to interact with a service like this.
Alan, any comments?
Yeah, I do actually. I think we're talking about a lot of stuff today.
Yeah.
Today in the world, very few places, very few airports and airspace let me say this a different way. Very few municipalities, cities, or government agencies, except the aviation agencies, control airspace. Right? United States of America, the Federal Aviation Administration owns the airspace, full stop. Right? There are a couple places.
Except for the government spots, and the federal.
Well, it's still those guys. There are some spots where the local municipality has exerted some authority on the operation of the airport. So while they don't control the airspace, they do control when and how loud you are in terms of using airspace. I live right next to John Wayne Airport in Orange County. It has a curfew. It has noise monitoring stations dotted all along the arrival and departure corridor. If you bust the noise limits, you get a letter. If you do it twice, you get a fine. You do it 3 times, you're banned from the airport. Right? So this is local populace exerting influence in a very localized way, but over aviation operations. As you start to see the democratization of urban air mobility, parcel delivery, where you have more flying things over more places that are not airports, I think it's going to be very interesting to see how other organizations start to exert their influence over aerial activities. One example I'll give you is just take urban parcel delivery as an example. Well, I have a lot of cars delivering packages in my neighborhood every day, right? Because it's just gotten so easy. We're in a building by Amazon, right? Like, man, it's so easy to buy stuff, right? Now imagine those are being flown in, and with great regularity and volume. I believe it is absolutely inevitable that homeowners associations are going to start to exert influence over this mode of operation. They can't control the airspace, right? But they can fine the resident who opted for the air delivery. So I think it's going to be really interesting to see how the municipalities, the counties, states interact with the federal government in terms of airspace access, modes of operation, routing, things like that. I think in terms of change, I think we're going to see a lot of change there. I think there's going to be a give and take. There's probably going to be a little bit of fight up front. I believe we certainly will reach equilibrium at some point, but that's a new dynamic that our populace is really never to deal with. This is to be really interesting.
I also think that another dimension to this is that urban air mobility doesn't exist in a vacuum. People still need to get to that vertiport and then fly somewhere and then get from that vertiport to their end destination. And we can all say, well, the ideal golden state is where, there's a pun there. The ideal, golden future is where the vertiport is exactly where you need to walk to, but that's just not going to be the reality a lot of the time. So if you just get in your car and drive to that vertiport, you haven't really solved a traffic problem for everyone else, right? If you take a ride share and you yourself leave your house and go to that vertiport, you still really haven't solved the traffic problem. And then if you are the only person flying from that destination to another destination, now you're creating an airspace problem. So this idea of how do we layer multimodal transit, mass transit, and rideshare together in a way that makes it really convenient for everyone to just leave their homes, get to the vertiports, then fly, then get to their end destinations without creating a log jam on either end. I think that's just another challenge that we're going to need to be thinking about before we go deploy all this. I know most of us already are thinking about that, but we want the public to be thinking about it too.
I think that the multimodal aspect is something that's really important to this. The population on the planet is growing. The congestion around our cities is growing. In many countries, there is a migration from rural settings to cities because there's more opportunity in the cities. So I see urban air mobility, air taxis like what Joby is trying to build, as just another part of the solution, a tool by which to move people where they need to go, when they need to go, and that will afford opportunity. It will afford business opportunity. It will afford more freedom for people to live out a ways, but still be able to work in an urban setting. So you can imagine being able to go to a park and ride and get on a vehicle, on a vertiport adjacent to the park and ride, and come downtown without having to fight your way through the traffic. You know, I, along with some of my colleagues, drove up here from Santa Cruz this afternoon. You can tell I don't have the coat. I have more of the Santa Cruz vibe, right? But we come through Half Moon Bay, we come into San Francisco, and the last 35 minutes of our drive was to go 4.5 miles. Imagine being able to just park at a park and ride and take that last step and be on the roof of the building you're going to, or at a vertiport that's been repurposed on the top of a parking deck to satisfy that.
All right, so Boeing has its partnership with Porsche, Uber, although you don't necessarily qualify as an aerospace company, but got the, like, Hyundai's getting into the game. So how do you see that? First of all, why is that happening? Let's talk about some of the advantages of that. And then I'd love to get the opinion up here on challenges that we see coming into that circumstance, that how those two entities, because they're coming at it from such different perspectives, how are those, where's the power balance there, and how's that going to shake out?
Yeah, so the reason we're so excited about our partnership with Hyundai that we announced at CES this year is they bring that scale that we want to bring to this aerospace world. I think helicopters today are produced in I think 1,000 per year globally, and so automotive companies are obviously used to much larger scales than that, and so bringing some of that expertise of how to build and design aircraft for scaled manufacturing is a great advantage that those companies are bringing. In terms of why they're interested in this space, I think you see Bell went through a transformation, as you said, from a helicopter company to a mobility company, and I think a lot of the automotive OEMs are seeing themselves the same way, where they're thinking about mobility not just in a consumer product that they take and deliver to a consumer, but from mobility from a much larger kind of ecosystem perspective of how do they deliver services to their consumers and provide beyond just the sale of a good. And so I think, and you see that with Bell's transformation, and I think the automotive companies, you see that as well.
I think that a right mix, and I don't want to oversimplify this, but I think the right mix of aerospace experience, automotive mass production know-how, and then digital transformation, right? I don't want to overlook that piece. Those three together, and then you could, dogpile a bunch of stuff on there and poke at me for forgetting about something. But those three, I think, are really, really important game changers. And you're not always gonna find like the perfect trinity of partnerships that makes that happen. So you're gonna have to home grow or reinvent or something. But that is kind of the trifecta that I think all future success is gonna be shooting for, is how do we make it scale? And what has aerospace learned to date that is still relevant, right? Largely relevant around reliability and safety and certifiability. And then what does digital transformation do to all this that takes everything we do and steps it up to a new level, a new game?
So I'll give you our perspective since you brought up our relationship with Porsche. We have a relationship with a number of other automotive manufacturers as well. Not ready to go public with any of those yet, but I think I can sum it up in one word, and that is learning. we know more than anybody about building large aircraft, right? And the focus on building large aircraft is building safe large aircraft, which means that you have to go very, very deep into your supply chain to manage quality all the way up the supply chain, because you simply can't wait until a part gets to the final assembly line to discover that it's bad, right? That has to happen at inception, as deep into the supply chain as possible so that you can operate efficiently at scale. That said, that's small scale, to Adam's point. Like, we make 1,000 airplanes a year, which is amazing. I mean, when you think about the 737 line at full production run is 55 aircraft a month. That's a lot of airliners, right? But it's still small in comparison to automotive production. So there are things we can learn there about how to do large-scale, rapid, just-in-time type manufacturing. The interesting contrasts, I think is the other half of your question, is where do the worlds collide as opposed to meet? And that is, the automotive world, the mindset is that a crash will happen. And it's about making that crash survivable, right? Our world is about not letting a crash happen. And that drives a completely different ethos through your design, your development, your certification, your testing. Not to mention the fact that those regulatory bodies are also quite different in terms of the way they view that same world. So as you try to bring these two worlds together, that creates some really interesting dynamics. Certainly some interesting debate, but usually that debate ends with a really enlightening kind of conclusion and a path forward to how this might work. I'll add one more comment to this, which comes more from the kind of marketing perspective, and this isn't really a Boeing position, but I think one of the things that we've seen rideshare do is really bifurcate our preference when it comes to transportation, right? If I'm going to own a vehicle, I have a brand preference that aligns with my personal brand. I have an affinity for a certain brand because I like to go do outdoors things, or I like a luxury vehicle, or I want a sports car. But if all I want is a ride, do I really care what shows up, right? What I do in the app is I select black, select X, depending on the experience that I want. And I think from the automotive perspective, well, that's scary as hell. Right? Because the automotive brands have actually built brand affinity based on your personal affinity to the brand and those things that make you tick. Just watch an automotive commercial today, right? They're tapping into these emotional, triggers that you have that make you want to go buy the BMW instead of the Mercedes-Benz. But when I book a ride, right? Oh, am I going out with my wife for dinner? We're gonna book a black, right? Is this on the expense report that is under the Boeing policy? Well, that's going to be an X today. So I think that's a really interesting driver. For us, it's about learning manufacturing at scale. Certainly, we're getting some learnings around consumer marketing as well. But I think for them, it's more existential around their marketing mix has got to change in this future dynamic.
Very much echoing what's been set up here, being able to produce at scale, learning everything we can learn about building high quality at high throughput vehicles is very important, and we see that as a big part of the partnership we have with Toyota. I agree that there's some downside to it, but I think there's a lot more positive. And one of the things we haven't talked about is the fact that there has been for quite a number of years an increased focus on automobile safety. So, everyone wanted to do what they could to make a safe automobile. But now that we have analog braking systems, adaptive cruise control, look at where Tesla's going with their autopilot, they have to actually solve many of the same problems that aerospace has been wrangling with for a long time, of very, very high availability, high reliability systems. So not to get too technical on you, but on the automotive side, there's a safety standard called ISO 26262 that the automobile manufacturers have been working with that, interestingly enough, has most of the same things that we need to do for aircraft software, aircraft electronics, aircraft mechanical systems. So we see a lot of synergy coming together, and one of the big problems that we have wrestled with on the aerospace side is it used to be that we could get mil-spec parts, and these things had been tested up one side and down the other by the Department of Defense, and you could count on them to work. We haven't had mil-spec parts since 1996, when the Defense Department said, nope, we're going to go with industry standards. So we are sourcing the same microprocessors and the same chips for all the different functions that go into your cell phone and go into gaming stations.
Wow.
And you know how often those things hang up and you get the old Microsoft blue screen of death, right? So the automotive sector has been working with this ISO standard. They have these things called automotive safety integrity levels. We have development assurance levels. And when we can get an automotive part that has been shown to satisfy the ISO standards, that gives us a lot more confidence that that component's going to work correctly than just sourcing something from a regular distributor. There's one other area of synergy that has the automotive and aerospace industry moving together, and that is there's a huge drive to have self-driving cars, right, autonomous vehicles. And all of us would tell you we probably are going to field vehicles to start that require commercial pilots. But down the line, we'd love to get the pilots off that airplane because we want to sell that seat. There's also a shortage of pilots. So we have to solve the same problems in terms of autonomy. And those of us who work on the aerospace side would tell you we probably have an easier path because of the FAA, because of the managed airspace, to be able to have autonomous aircraft before you will have your self-driving cars.
Real estate, certainly. Right? If you can decouple from the existing road networks in any way, then you change the base assumptions of the real estate industry, right? Location, location, location. Well, actually, maybe it becomes like location, location, flight time, right? Like, who knows? Like, I think that's going to be really fascinating to see the dynamic. And the analogy that I like to use, because I just get a kick out of this, is if you go to like the older cities in the United States of America, it's, for whatever reason, the lower two floors are the most ornate floors. And then as you go higher than the lower two floors, they become less and less ornate until you get to the very top floors. And then they get very ornate again. You go, what the heck, right? Well, the truth is, before the elevator, the first two floors were the floors everybody wanted to live on. Right? So you pump them up and you peak priced your lower two floors, and then everybody had to climb the stairs to get to the upper floors. Once the elevator came on, everybody wanted to be on the top floor. Right? So I think it's really interesting how a small technological invention like that can completely transform the pattern of life of the consumers that are in that system. And I think when you start to look at UAM and the fact that you can now really live anywhere, that's fascinating to me. So that's kind of my put for that.
Yeah, there's a concept called Marchetti's constant. It's an Italian physicist came up with this, that observed that throughout human history, from ancient Rome, the human average commute time is 30 minutes each way, and that has remained true throughout history, with from walking to horses to horse-drawn carriages to rail cars.
Marchetti didn't live in the Bay Area.
Yeah, so obviously there's a lot of exceptions to the rule, but you see that cities have adapted to more than any technological advance that kind of drives how cities are shaped. It's how we get to and from the places we want to go, and so changing from being able to being stuck at 30 miles an hour, if you're lucky, going up and down 101. To flying at 150 miles an hour over traffic and using that three-dimensional bandwidth that effectively is opened up. You're going to continue to see just massive changes in the ways that cities are shaped, and just the way that people move around. So.
I think, and this is a bit further out than the immediate deployment of UAM, but I think when operating at scale, the sheer integration and autonomous management of autonomous systems So you think of the aircraft as a system, and the vertiport as a system, and UTM as a system, and maintenance processes as a system. The system of systems has to be autonomously managed by optimization software, and a bunch of optimization softwares working together with like open standards. To no level we've ever seen to date have we, to no level that we've seen to date will there be any kind of this magnitude autonomous systems. The reason I think this is really important is because as we start talking about space, I'm going to get really crazy here for a second. As we start talking about space, right? Start talking about we want to fly people to Mars and to the moon and all this stuff, right? The person to technology ratio gets even smaller than what we're talking about with rideshare. So our ability today to manage autonomous fleets and autonomous logistics and autonomous supply chains is all going to go on as we explore, greater than the vertical dimension. So not to get too meta with it, but I really do think it's like this roadmap of like mastering our space here and mastering our space in space.
I actually
That was
think
intentional.
I think that's actually an incredibly important point. We want to integrate into the existing air traffic control system, but the air traffic control system we have now simply cannot scale to deal with this.
We need packet switching, auto packet switching.
Oh, well beyond that, we need to be able to use neural networks to manage the efficiency of all this, react in real time to issues where someone may be having a hard time getting into a vehicle, where they've left something behind and now that particular airplane can't dispatch, so it's going to be a minute and a half late getting off the pad. There's another one coming in to land. Humans cannot manage all of that. So, you pick up any trade journal right now in the high-tech industry, and it's all about AI. It's all about neural networks, deep learning. This is where we are really going to see this technology come to bear. I truly am a believer that everything to do with neural networks and deep learning is going to revolutionize every facet of our life. And certainly our transportation systems. Because, if you're flying into Hartsfield Airport in Atlanta on a hot summer day with thunderstorms in the area, and you tune in to the terminal area air traffic control, you cannot measure any dead space. Between the pilots reading back their directions and air traffic control commanding all the airplanes coming in and out of that space, there is simply no more room to handle it in our existing system. So the whole system has to evolve. So as that system evolves, there's entire new occupations, technology-based occupations that we do not know now that are going to come into being over the next few years. It is an incredible time to be alive and be working in this type of tech.
But we also have a family of unmanned logistics drones, industrial level drones for like warehouse to warehouse or hub spoke type distribution. And all the problems are the same, whether or not there's a human on board. You still have to master that airspace integration. You still have to master the fleet management piece of it, and to drive down cost, you have to master the fleet management all the way back to predicting when to fulfill that supply chain. So I think it all still applies.
Maybe it doesn't have to be so quiet.
Possibly.
I think it's a great question. And I think we probably all focused on UM because Brent told us to. But cargo is a great use case, right? Because it opens up areas of operation that actually help you minimize ground risk. So when you think about the certification of an air vehicle, right? It's yes, everybody goes right to the air risk. Is the thing airworthy? Is it going to fly? But you're also mitigating the ground risk. Right? So if through the concept of operation, short ConOps, what we say, is for a use case that has you fly over the tundra because you're delivering cargo, or you can afford to take a roundabout way and minimize ground risk, then absolutely, that's a viable use case to help propel the technologies, concepts of operations, regulations in this space. And I think it's actually a very viable business case as well, right? Because you could start to look at the current hub and spoke air transit network for cargo, which is based on, back to my earlier point about utilization, utilizing your 767 to the max, consolidating that cargo between 2 points in your hub and spoke network, and then resorting and distributing that cargo out to your destination spots. If you could start to transform that network into more of a peer-to-peer network, so that you reduce the dependency on your hub, which then reduces your congestion due to air traffic management, airspace flow, separation constraints, things like that, well then yeah, you may actually have a very transformative and successful offering. So the short answer is, I think all of us are looking at cargo as a very real business proposition. It's just not as cool as the Jetsons.
Well, you're already seeing food. We're actually already doing food deliveries on the Uber Eats platform. And so, your question about why, obviously both of us, or all of us, think that they're both good use cases, but when you think about the cost of a flight operation, whether it's with a UAS or a person moving vehicle, in the early days it's going to be higher and it's going to come down as we get to scale. And so moving people is a very time critical endeavor, and people really value their time. And so what we've actually found with Uber Eats is there's another great time critical use case that allows us to absorb some of these higher costs in these early days because people don't want their fries to get soggy. And so we're actually able to expand the radius we're able to serve each restaurant because we're able to get that food faster, farther, and actually create new opportunities for restaurants. And so that kind of time critical use case is a great place to start while the costs are still high as the costs come down. The range that we talk about in terms of, we've got actually a set of public requirements that we've done a lot of market analysis, used the rich data set that Uber has on how people move around cities. We've set our requirement at 60 miles for the max range of these aircraft. And we think that's really the sweet spot of where you're really maximizing your time savings, but keeping that network density that John talked about in terms of that utilization and load factor. And so that's that kind of the 25 to 60 mile range is kind of the sweet spot we're focused on. And in terms of the cost that you mentioned, we project within the first couple of years of operations, taking advantage of the technology improvements where you have electric motors instead of turbines, and the utilization and load factor benefits, that we can be at UberX per mile prices in those kind of first couple of years of operation. And when you layer in autonomy and scaled manufacturing through these automotive partnerships, we actually think we can approach 50 cents a mile, which is about the same as driving your own car.
Wow.
Hey Adam, question for you. To your right. For the pilot you launched in New York City for Uber Air, you said you learned a lot of things. Some of them you've mentioned, but what were some of the other items, like price elasticity, demand greater or less than expected, those types of things?
Yeah, it's been a great learning platform. And again, it actually goes back to the initial question or initial answer I gave around community acceptance and do people see themselves using this. We offer the price that we offer is actually just $200 a seat, which any other mode to get you to normal Uber is going to cost you about $100, and we're saving you people at least 30 minutes on average. And so like from a rational perspective, it's a really strong value proposition. And so what we're trying to understand is how do we get people to see themselves as a helicopter person, right? Most people wouldn't, when they go to think about how they're going to get to the airport, they don't think about themselves, like that option doesn't really cross their mind. And so we're trying to figure out how do we kind of train people to understand what time value trade-offs they're really making. And we think when people really are presented with the real option sets, they're choosing it most of the time. And so we've seen a really strong correlation of awareness and demand.
As I'm walking, I'm going to ask a quick question. So you guys said that you're starting with a place for the pilot, right? But you want to get the pilot out. Are you starting with a place for the pilot just because of the consumers? Or are you starting with a place for the pilot because that's the most comfortable place to start?
I think it's both, right? Like, if you want to get operational learnings, you want to go fly. And currently the rule sets, if you look at the holy trinity of pilot certification, aircraft certification, operational certification, it's all written very well. The regs contemplate just about every use case we can think of. So if you got a pilot in the airplane, you can go start to do these things, right? You can start to explore, just like Uber is doing with Copter in New York, right? You can start to explore the other aspects around the business and discover some of those unknown unknowns. So that's one reason. I think the second reason is it helps you bring the regulator along for the ride in a more collaborative way, which is really, really important. This is new space, and the regulator's job is to keep bad things from happening. So they have a very natural risk aversion built in, and for very good reason, right? So trying to leap too far too fast without engaging that community and basing it in something they know, psychological anchoring, right? It's very hard to then affect the kind of change. But if you start with a known and you start to then explore gradually changing those things, you know, you look at airliners, right? Most airliners, the crew is touching the airplane about 5 minutes worth of the flight, literally. They steer the airplane onto the runway, they push the throttles forward, lift the gear up off the ground, and then hit a button, right? As a matter of fact, my buddy's a captain for SkyWest, and he tries to fly autopilot as much as possible because it minimizes his risk of doing something wrong that might affect his personal career. Right? Busting at altitude, missing a radio call, missing a heading, right? Like these things matter to that community, so he actually opts to be flying under automation as much as possible. But that introduction happened starting with the pilot in the seat and then introducing automation over time. And you know, to come back to our automotive question, I think we're seeing some of those similarities with our automotive partners, right? They're introducing individual components of autonomy in segments, right? In bite-sized chunks. And, you know, earlier, well, not earlier this year, it's February. I forget what year we're in. But I rented a car last summer, and it was the first rental car I got in where the default mode for the steering system was on lane assist. I didn't opt for it. It was already on. So I'm driving and I'm feeling like the wheel kind of nudged me a little bit, and then I finally realized, oh, it's built in. It was easy. It was an incremental addition to my driver experience. I still had total control, but it was fascinating. So I think there's a couple real reasons why you start with a pilot first.